Here we are in a parking orbit of 118 miles high. After orbiting the Earth 2 or 3 times and confirming all systems are good, it's time to ignite the third stage one more time for about 6 minutes. We call this the translunar injection. This is what sends us away from the Earth and towards the Moon. The S-4B is now completely useless. Remember, that's the third stage at the top of the Saturn V. The spacecraft lunar module adapter panels detach, exposing the lunar module. The command and service module do a complete 180-degree turnaround. The command module must dock with the lunar module and pull it out. In space, temperatures are a lot more extreme. There was a real danger of parts of the spacecraft freezing or other parts getting too hot. To prevent this, the spacecraft was now put into a slow roll, so that there was an even heat distribution. This was called passive thermal control, but also nicknamed the barbecue roll. If we ignore the Moon, this is what our flight path will look like. We're still orbiting the Earth, but we're in the shape of an ellipse, heading all the way out into the middle of nowhere. With the Moon, however, everything starts to make a little more sense. At the time of launch, the Moon is about here. During the next 3 days, their paths converge. Just to be clear, this is the Earth and the Moon drawn to scale. I animated out of scale so it's easier to see the flight paths. So, the Moon's gravity changes where the spacecraft flies. This is called a free return trajectory. If something were to go wrong with the engines, the astronauts would still be able to get home. On the other hand, if all systems are go, it's now time to enter lunar orbit. This is called the lunar orbit insertion. As the spacecraft passes behind the Moon, the service module engine was fired up for about 6 minutes to slow the spacecraft down. At times like this, they would lose contact with mission control because they are on the far side of the Moon. Unfortunately, this is where a lot of important events happened. The guys at mission control just had to sit tight until the astronauts came around the other side. Now it's time for the main event. When the astronauts are ready, 2 of them get into the lunar module and get ready to land on the Moon. One of them stays behind and continues to orbit the Moon. Side note, the lunar module was usually just called the LEM, and when the command module and service module were together, they were usually referred to as the CSM. The LEM now extends its legs. After making sure everything still checks out, the LEM separates from the CSM. The LEM must get to a safe distance of about 2 miles away before firing the descent engine. The engines fire up for about 30 seconds. This is called the descent orbit insertion. This puts the LEM down to about 50,000 feet above the surface. Now the engine fires up again for powered descent initiation. The windows are initially pointed down, but as we get closer to the surface, the windows will be facing forward to give the astronauts a good view of the surface they'll be landing on. The landing site needs to be on level terrain and away from any big boulders. There's a limited amount of fuel, so the astronauts can't take too long to land. And finally, touchdown. Now it's time to step down the ladder, say some historic words, plant the American flag, get some rock samples, and do some science. After the lunar stay was over, it's time to take off from the surface.